Assalamu alaikum and welcome to IMC412 Fundamentals of Information Science. I'm Dr. Zaidi, and I'll be your guide as we explore how people, technology, and knowledge connect to shape our digital future. Information science isn't just about computers or libraries, it's about how ideas move, how data becomes meaning, and how knowledge powers every decision we make. By the end of this course, you'll see that every search, every message, and every click tells a story about how humans and information work together to build our world. Here's what we'll cover in this chapter. First, we'll break down the basic concepts, theories, and definitions of information science. Next, we'll trace its evolution, from early classification systems to today's AI-driven knowledge networks. Finally, we'll look at information science as a discipline, exploring its many branches and professional roles. Think of this session as your map of the information landscape, where we came from, what we study, and where the field is headed next. Information science is not just about computers or libraries, it's about understanding the relationship between information, people, and technology. It is dynamic and multifaceted, meaning that it constantly evolves as new technologies and social needs emerge. As an interdisciplinary field, it borrows ideas from computer science, library science, cognitive psychology, and communication studies. These perspectives help us analyze how information is created, processed, communicated, and used in different settings, from social media platforms to healthcare databases. Ultimately, this field aims to improve how society handles data, information, and knowledge so that individuals and organizations can make better decisions. In short, information science provides the theoretical foundation and the practical tools for solving modern problems in our digital world. Information is at the heart of almost everything we do. Whether we are teaching, running a business, managing a hospital, or governing a country, information drives every decision. As Rowley and Hartley, 2020, remind us, information is a fundamental resource for progress and innovation. In the digital age, this concept has expanded beyond books and documents to include text, images, audio, videos, and symbols. Essentially, when data is processed, structured, and made meaningful, it becomes information. Information supports understanding and guides action. Over time, scholars across disciplines, from sociology to computer science, have refined what the term means, which shows just how broad and dynamic this field has become. Information science can be described as the systematic study of how information is collected, organized, stored, retrieved, and disseminated. It emerged in the mid-20th century, a time when the world faced an overwhelming growth in recorded data, largely due to rapid technological progress. To manage this explosion of information, researchers began integrating principles from multiple areas, particularly computer science, library and information management, and cognitive studies. Modern information science now deals with subjects such as digital libraries, information retrieval systems, metadata, and human-computer interaction. In the era of big data and artificial intelligence, information itself has become a valuable asset, one that drives innovation, supports business strategy, and even influences national policy. As Bodden and Robinson, 2020, point out, mastering this discipline is essential for navigating the knowledge-based economies of today. Before we move on, let's take a moment to understand what we really mean by science. Science is a systematic way of studying how the world works, both the natural and social world, using observation, experimentation, and careful analysis. According to Schneider and Gerstel, 2020, science helps us explain and predict things in ways that are testable and backed by evidence. It's about reducing bias, repeating results, and constantly improving our understanding of reality. Think of science like a flashlight in a dark room. Each observation and experiment lights up another corner of what we didn't understand before. It doesn't show us everything all at once, but step by step, it brings clarity. Now, when we take this scientific approach and combine it with the study of information, something powerful happens. We begin to apply logic, analysis, and critical thinking, not just to understand the world, but to understand how information itself is created, shared, and used. And that's why we call it information science, the flashlight that doesn't just reveal knowledge, but also helps us see how knowledge works. Before we dive into specific theories, let's first talk about what a theory really is. A theory isn't just an abstract idea, it's more like a map. When explorers travel through unknown territory, they rely on maps to make sense of where they are, where they've been, and where they're heading next. In science, theories serve the same purpose. They guide us, helping us navigate the complexity of the world and understand how things are connected. You can also think of a theory as the blueprint of a building. Without a blueprint, you might have bricks and materials, but no structure. Similarly, without theory, data and observations are just scattered facts with no framework to hold them together. Theories give structure and depth to any scientific discipline, and information science is no exception. Let's explore several influential theories that shape how we study information behavior and system design. First, the information behavior theory by Thomas D. Wilson, 1981, explains how individuals search for, use, and share information. It underpins user-centered designs in libraries and information systems. Second, the DIKW hierarchy, data, information, knowledge, wisdom, proposed by Ackoff, 1989, describes how raw data transforms into meaningful wisdom. It's the backbone of decision support and knowledge management systems. Third, the information grounds theory by Karen Fisher and Pettigrew, 1999, shows how informal social spaces, like cafes or online forums, encourage information sharing. This guides how we design digital communities and learning spaces. Fourth, the knowledge gap theory by Titchener and colleagues, 1970, highlights inequalities in information access caused by socioeconomic differences, reminding us why digital inclusion truly matters. Fifth, cognitive authority theory by Patrick Wilson, 1983, explores why people trust some sources over others, a key idea in understanding credibility and misinformation. And finally, Elfreda Chatman's, 1996, information poverty theory examines why certain groups lack access to information, especially marginalized communities. Together, these theories connect technology, human behavior, and society, forming the intellectual foundation of information science. Let's take a closer look at the DIKW hierarchy, one of the most important frameworks in information science. Imagine a pyramid, where each layer represents a different stage of understanding, from simple facts to deep insight. At the base is data, raw facts and figures. These could be numbers, readings, or observations with no meaning on their own. When data is organized and interpreted, it becomes information. Information helps us see patterns, how things relate, what's changing, and what might matter. When that information is combined with experience and understanding, it becomes knowledge. Knowledge allows us to make sense of why things happen and how they connect. And finally, when we apply that knowledge with judgment, reflection, and foresight, it becomes wisdom, the ability to make sound decisions in uncertain situations. Now, let's bring this to life with an example. Think of a fisherman at sea. Each morning, he records data, the wind speed, the water temperature, the direction of the waves. When he notices that certain wind directions bring stronger tides, he's turning those readings into information. After years of sailing, he develops knowledge, understanding how changes in color, smell, or the behavior of seabirds signal a shift in weather. And when he senses a storm brewing, even before the sky darkens, and decides to return to shore, that's wisdom. He's no longer just reacting to data, he's interpreting signals, connecting experiences, and making choices that ensure safety and success. That's the essence of the DIKW hierarchy, moving from raw observation to informed, intelligent action, just like a wise fisherman who reads the wind, the water, and the coming storm. Now, let's trace how information science evolved over time, from early documentation to today's digital landscape. In the documentation era, during the late 19th and early 20th centuries, pioneers like Paul Audlett envisioned a universal network of knowledge. His idea of the universal bibliographic repertory was essentially a blueprint for the internet decades before it existed. Next, the information retrieval era of the 1940s to 1960s brought the first automated data systems. Vannevar Bush's Memex concept, 1945, inspired hypertext and eventually the World Wide Web. During the information systems era of the 1970s and 1980s, J.C.R. Licklider's man-computer symbiosis proposed interactive computing, while Ted Nelson's project Xanadu introduced hypertext, linking documents digitally. F.W. Lancaster further advanced online retrieval and library automation. Finally, in the digital and networked era from the 1990s to today, Tim Berners-Lee revolutionized global information access by inventing the web. Scholars like Peter Ingwersen and Christine Borgman expanded the field into digital curation, informetrics, and open science. Each era demonstrates a clear pattern. As technology evolves, so does the way we handle information, from physical documents to intelligent data ecosystems. Information science is a broad umbrella that covers many specialized areas, each focusing on a different stage of the information lifecycle. Let's take a quick tour through these core branches. Library science is where it all began. It focuses on organizing, classifying, and retrieving information, both in print and digital forms. Think of it as the GPS of knowledge, helping users find exactly what they need, when they need it. Information management views information as a strategic asset. It's about making sure the right data reaches the right person at the right time, supporting decisions and operations in business and government alike. Knowledge management captures and shares what people know, their skills, experiences, and insights, turning them into reusable knowledge that fuels innovation and learning within organizations. Records management deals with creating, storing, and disposing of records responsibly. It ensures accountability, transparency, and compliance with laws and policies, a key part of good governance. Archival science safeguards the authenticity and long-term preservation of valuable records. Through digitization and metadata, archivists protect our collective memory so future generations can still access it. And finally, museum and heritage information management brings technology into the cultural world. It uses digital systems to preserve, catalog, and exhibit cultural artifacts, allowing people anywhere in the world to explore history online. Together, these sub-disciplines work like the organs of a living body, each with its own role, but all ensuring that information remains accurate, accessible, and meaningful across time. So, why do we need all these branches of information science? Because information is powerful, but only when it's managed well. Without structure and stewardship, information becomes noise. Library science, information management, knowledge management, records management, archival science, and museum information together create the systems that turn raw data into reliable knowledge. They ensure that information is organized so it can be found. Records are protected so history isn't lost. Knowledge is shared so organizations can learn and grow. And heritage is preserved so culture and identity endure. Think of it like a city of knowledge. Libraries are the roads that guide us, records are the laws that protect us, archives are the memory that connects us, and museums are the landmarks that remind us who we are. Without these systems, our digital and physical worlds would fall into disorder and disconnection. That's why these sub-disciplines matter. Together, they make sure that information serves people, communities, and the future. Information science is a broad umbrella that brings together many specialized areas, each addressing a different stage of the information lifecycle. Yet, they are not isolated fields, they complement one another, forming a continuous chain from creation to preservation. Library science focuses on organizing, classifying, and retrieving information in both physical and digital forms. It ensures that users can find, evaluate, and use reliable sources efficiently, feeding the foundation for other information practices. Information management builds on this by treating information as a strategic asset. It ensures that the right information reaches the right person at the right time, turning library organized knowledge into actionable insights for decision-making. Knowledge management then captures what people learn from using that information. It transforms experience into documented knowledge, supporting innovation and continuous improvement, which, in turn, strengthens organizational information systems. Records management complements knowledge management by ensuring that the official documentation of actions and decisions is properly created, stored, and disposed of. It upholds accountability, transparency, and policy compliance, ensuring that knowledge and data remain trustworthy. Archival science extends the lifecycle further. It preserves records of enduring value, maintaining their authenticity through digitization and metadata. This ensures that evidence and heritage are never lost, even as technology changes. And finally, museum and heritage information management connects the past with the public. It uses digital platforms to curate, exhibit, and share cultural heritage, making historical knowledge accessible for learning and inspiration. Together, these sub-disciplines form an interdependent ecosystem. Library science organizes, information management distributes, knowledge management enriches, records management secures, archival science preserves, and museum management celebrates. Each complements the others, ensuring that information remains accurate, accessible, and meaningful across generations.
That brings us to the end of our first lecture on the fundamentals of information science. Today, we've explored what information really means, how it's created, organized, and transformed, and how information science connects people, technology, and knowledge through both theory and practice. As you reflect on today's session, think about which part excites you most. Is it the technology that powers intelligent systems, the human side that studies how people seek and use information, or the knowledge management aspect that drives innovation and decision-making? Whatever sparks your interest, remember this: information science is the invisible engine behind everything we do in the digital age. From Google searches to social media, from data analytics to AI, it's the discipline that makes our world more connected, intelligent, and human. In our next class, we'll go deeper into how information is organized, retrieved, and evaluated in digital systems, the foundation of how libraries, platforms, and AI tools manage knowledge today. Thank you for listening, and I look forward to our discussion next week. Until then, keep observing how information flows around you, because every click, every search, and every idea begins with information science.